Hello everybody, I'm Eric Hatter, Chief Mechanical Officer at the Grand Canyon Railway. Welcome to our mechanical shop here in Williams, Arizona. Today we're going to spotlight the 4960 steam locomotive. We're going to talk a little bit about its history, why it's such a significant locomotive in railway preservation. We're going to talk a little bit about some of the modifications and things that we've done here at Grand Canyon Railway to improve this locomotive. And we're going to talk a little bit about what it's like to operate this locomotive on a trip from here to the Grand Canyon, so stay tuned. 4960 was built in 1923 by the Baldwin Locomotive Works of Philadelphia, Pennsylvania for the Chicago, Burlington, and Quincy Railroad. It is a 282 locomotive classified by its wheel arrangement, also known as a Mikado. 4960 spent the first part of its career hauling freight throughout the Midwest. By 1960, the Burlington had retired most of its steam locomotives in favor of diesels. However, it kept several steamers on the active roster for use with special events and public outreach. 4960 was one of those. During this time, it was nicknamed the Teacher because of all the school groups it hauled on field trips. In 1966, the Burlington canceled its outreach program and 4960 was sold to the Circus World Museum in Baraboo, Wisconsin. From there, it was sold to the Mid-Continent Railroad Museum in nearby North Freedom, Wisconsin. In the early 1980s, 4960's excursion career redeveloped when it was leased to the Bristol and Northwestern Railroad in Bristol, Virginia. Unfortunately, this operation was short-lived. Grand Canyon Railway purchased the locomotive in 1989. When 4960 arrived in Williams, Arizona, it was in pieces. Most of the parts came by rail, with the frame on one flat car, the boiler on another, and the tender still on another. The wheels did not arrive at all, having been sent to a shop in Alabama for repair before arriving in Williams by truck. Restoration by Grand Canyon Railway took several years and cost around $1.6 million. Finally, 4960 made its debut in June of 1996. It has operated on GCR every year since and has run over 100,000 miles between Williams and the south rim of the Grand Canyon. So, once 4960 arrived here at Grand Canyon Railway, we've done quite a few modifications to this locomotive in order to bring it up to a little more modern standards, quite a bit different from the historical perspective. One of the first things you notice is it's got a new tender. This is a much larger tender than the original. This came off of a Sioux Line 482 locomotive. It holds 3,600 gallons of fuel and 18,000 gallons of water. The fuel that we're burning now is recycled vegetable oil that's picked up by another supplier, a third-party supplier that picks it up from restaurants and manufacturing facilities in northern Arizona, and they deliver it to us before each run. One of the other things that you'll see different on this locomotive is the smoke box. We've modified the smoke box, made a new one. It's a little smaller than the original. It also has a different headlight and bell configuration. We also modified the sand dome up here. The sand is used to go down to the wheels for traction, and we made that a little smaller as well. After the 2004 season, we manufactured and installed a new exhaust system. Known as a lemp bore, it's more efficient than the original. Here you see the inside of the smoke box, and the lemp bore exhaust is here in the bottom. The parts were custom designed by a consultant and manufactured by GCR staff. The stack was newly manufactured as well at that time. So at the end of the 2007 season, we modified the locomotive by converting the main driver bearings from a grease lubrication system to an oil lubrication system. And that's part of what we see here. This is a mechanical lubricator that we added. It uses a biodegradable oil specially formulated made out of animal fats to lubricate the main bearings on the locomotive. One of the other things we've incorporated on this locomotive is a new feed water system. This is a Chinese copy of a Worthington SA. It has three main components. The first one is a cold water pump, as you see right here. It takes water from the tender and through a steam-driven centrifugal pump, pushes it up to a heat exchanger up in the smoke box. The heat exchanger is up here at the top of the smoke box. So your cold water goes up into the heat exchanger. It gets heat from the fire in the smoke box or from the heat in the smoke box, as well as it also picks up some of the exhaust steam that comes out of the pistons, and then it mingles up there. From there, the hot water comes down here to the hot water pump, which is on the pilot deck. And that, through a reciprocating pump, pushes the hot water up into the boiler check and into the boiler. So here we have our injector that is another way of taking water out of the tender and pushing it up into the boiler. So this casting was something that we made ourselves. We had custom made back in 1999, and we have one incorporated on both of our steam locomotives. In operable condition, 4960's engine and tender are 94 feet long and combined for a total weight of 310 tons. It runs on a boiler pressure of 200 pounds per square inch and is rated for 58,000 pounds of tractive effort. The drive wheels are about 63 inches in diameter, and it is designed for a top speed of around 65 miles per hour. However, Grand Canyon Railway only operates at a top speed of 40 miles per hour. So these are the fireman's controls of the locomotive. This is the main firing valve. So the fireman is going to be able to control fuel flow from the tender behind us to the burner, which is down here in the firebox. And this valve, you can manipulate this valve in order to control the volume of fuel that flows into the firebox. Now, once the fuel goes into the firebox, it needs to spread out and be fanned out. We do that with something called an atomizer. That's controlled right here. That's a jet of steam that spreads out through the firebox. We also have a blower that's used in order to create artificial draft when the locomotive is sitting still. And then we've got a series of gauges over here. We've got a pressure gauge right here and water glasses on both sides. The water glasses show the actual water level in the boiler. It equalizes water in the glass with water back up in the boiler. And so lets them know whether the boiler is too full or needs more water. We also have controls here to control your feed water pump and also your injector. So this is the engineer's controls. Here's your throttle, controls steam flow from throttle valve up inside the steam dome, top of the boiler, down to the pistons. Here's your brakes. So we've got a automatic brake and an independent brake. The independent brake controls the brakes on the locomotive by itself, and the automatic brake controls the brakes on the entire train. This is a reverser, so this controls the direction of the locomotive from forwards to reverse. In the middle is a neutral position. It also works a little bit like a manual transmission. The farther you go away from center, the more power you're putting the locomotive. But as you get the locomotive going and you don't need as much power, then you can hook it up a little bit towards center, so you're using a little bit less steam. It's an efficiency device, basically, in order to use less steam in order to maintain your speed. Gauges here to control your air brakes, and this one is boiler pressure. This is actual pressure going to the cylinders. Again, a water glass there, and your speedometer, and your whistle. Right here, what's missing is where our box goes that we use to control the diesel behind us. And this is something that we developed ourselves. Other railroads have done something similar, but we made a custom version for ourselves. So we've got a diesel running behind us, which is a normal operation because we usually need 2 locomotives in order to pull our heavy trains. Then the engineer here can control the diesel locomotive from a box right here. So this is our custom manufactured MU box. MU stands for multiple unit. It runs off a programmable logic controller, or PLC, so basically it has a small computer for a brain. Up top is the throttle control. It also has controls for generator field, locomotive direction, and dynamic braking. The gauge on the bottom shows actual electrical current going to the drive motors. Over here is sand control in order to put sand down on the wheels, on the rails right in front of the wheels in order to use it for traction. And then we've got your bell control right here, and also your cylinder cocks, which blows steam out the sides of the cylinders in order to get condensation and things out. So here in the back of the cab, in the front of the tender, we have a sandbox. So the fireman will use sand here in order to scour the soot off of the flues. When the engine is working hard, he'll shovel the sand into the firebox and scour the soot off, and it'll come out the stack, make big plumes of black smoke for brief periods of time. Thanks a lot for joining us on this tour of 4960. If you'd like some more information, check out our website, www.thetrain.com, or our Facebook page, or our YouTube channel. We've got lots of great information there. And also check out our website for upcoming Steam schedules for when the locomotive is going to be operating next. Thanks again.